on this problem here, a little bit more complicated second derivative that I'm going to need to work on. But again, I just need to find all the points of inflection of the function. So I need to find the second derivative and set it equal to 0 or where it does not exist, and then see if that is on an inflection point. So to start off with, before I kind of get going, I'm going to find that the domain of this function is negative infinity to positive infinity. So this is a continuous function. I know that because don't ride lions. Denominators, there is no value of x that can make that denominator 0. There is no number I can square that's going to give me negative 1. No number I can square that'll give me negative 1. So I'm not really worried about any denominators. I have no radical signs with an even index. I have no logarithms. So the domain of this function is negative infinity to positive infinity. So to find the derivative, I'm going to do a little bit of a change here. I'm going to make this x times x squared plus 1 to the negative 1. Because I would just rather work with the product rule than work with the quotient rule in this case. So uv plus uv. So my first derivative, let's change colors, y prime is going to be equal to, well, 1 times v's, because 1 is the derivative of x, so I'm going to have x squared plus 1 to the negative 1, plus u, which is x, times the derivative of v, which would be negative 1 x squared plus 1 to the negative 2 times the derivative of the inside, which would be 2x. So I'm going to start working on simplifying this a little bit. So I'm going to have this is equal to x squared plus 1 to the negative 1 minus, well, 2x squared times x squared plus 1 to the negative 2. So I got this times that, use my negative sign over here. So we're getting a little bit more simple. What I'm going to do to try and simplify it a little bit more is I'm going to factor out this x squared plus 1 to the negative 2. And that gives me, so I have x squared plus 1 to the negative 2 times, well, this would just be times x squared plus 1 minus 2x squared. You can work that out. Make sure you understand how I factored out this from both these pieces here by kind of re-multiplying them in. That'll give you a good sense of how to do that. And so I have now, so I can work a little bit with like terms here. What I'm going to do is I'm going to say, okay, first of all, I'm going to put this piece here in my denominator. So that's going to be x squared plus 1 squared. And here I have a positive x squared, a positive 1, minus 2x squared. Well, I have like terms right here and right here. So I have negative x squared plus 1 over the denominator, and that's my y double, that's my y single prime. That's my y prime. So while I'm at it, I just may as well note again here that the domain of y prime is also all real numbers. There's nothing that I can substitute in for x that's going to make my denominator 0. No radical signs with an even index. No logarithms. So that's my domain of that. Now I need to find my second derivative. So y double prime. I'm going to have to use the quotient rule right now. So I'm going to go uv minus uv all over v squared. Okay. So u prime would be negative 2x, so times v x squared plus 1 squared, minus u, so I'm going to put in parentheses, negative x squared plus 1, times v prime, which would be 2 times x squared plus 1 to the first power, times the derivative of the inside, which would be 2x. And all of that will be divided by x squared plus 1 squared, meaning to the fourth power. So now we got to do a little bit of simplification here. Not much I can do with the first term in my denominator yet, so I'm going to leave it at negative 2x, x squared plus 1 squared. And for my second term, well, it's still going to be a minus sign. I have a 2 and a 2x right there, so that would give me 4x times negative x squared plus 1, x squared plus 1. All of that is still divided by x squared plus 1 to the fourth. Well, let's factor out from my numerator an x squared plus 1. Because I can see in my denominator I had x squared plus 1 also. So I think that'll help us lower the power, lower the degree a little bit. So if I take out an x squared plus 1, it's going to be times minus 2x x squared plus 1 minus 4x times negative x squared plus 1. This one got factored out. All divided by x squared plus 1 to the fourth. So what I'm left with, that's going to go, and that's going to reduce to 3, is negative 2x x squared plus 1 minus 4x negative x squared plus 1 divided by x squared plus 1 to the third power. Let's do some distribution in my numerator. So I'm going to have negative, because I'm going to have like terms, I can see it. I'm going to have negative 2x cubed minus 2x plus 4x cubed, the negative times the negative, minus 4x. Make that a 4x. Again, over x squared plus 1 cubed. Well, that is equal to negative 2x cubed, positive 4x cubed. It's equal to 2x cubed minus 6x over x squared plus 1 cubed, which I can simplify a little bit more, and I can pull out a 2x from the numerator, and I get x squared minus 3 over x squared plus 1 cubed. So this is my y double prime. And I want to find out where it's equal to 0 or where it does not exist. Well, I can look at it here and I can see that it's still going to exist everywhere. The domain of this is still going to be negative infinity to infinity, because there are no values of x that are going to give me a 0 on my denominator. But I do have y double prime equal to 0 at x equals 0 and at x equals plus or minus radical 3, because x squared minus 3 equals 0, x squared equals 3, x equals plus or minus radical 3. Remember now, I'm looking for inflection points. So I need to set up my number line. And those are the possible places where I will have inflection points. So here's 0, 1, 2, 3, -1, -2, -3. Radical 3, I'm not really positive what exactly it is. I could plug it into my computer. But I know it's greater than 1, and I know that it's less than 2. So it's somewhere right in here. Here is radical 3. Here is negative radical 3. And then I have another interval right there possible at 0. And I need to test some numbers. So let's test. Let's get a different color. Let's test y double prime of -3. That's a number over here in my far left interval here. So I would have 2 times -3 times -3 squared minus 3 divided by -3 squared plus 1 cubed. And one thing I can see right now is that no matter what, this bottom, my denominator here, is always going to be positive. Because there is no number that can make this negative. So this is always going to be positive, and if I cube a positive number, it's always going to be positive. So I know that I'm going to have a positive in my denominator, and my numerator, I'm going to have this is going to be a negative, and this part right here is going to be a positive. So negative times a positive is a negative. So that is going to be a negative. So this interval over here is going to be a negative. Let's test y double prime of something in the next interval. Let's test it on -1. Well, again, I know my denominator is always going to be positive. So I'm only concerned about my numerator. Well, I would have 2 times -1 times -1 squared minus 3. This is going to be a negative. This is going to be a negative. A negative times a negative is a positive. A positive divided by a positive is a positive. So this interval here is going to be positive. Let's test y double prime of +1. Again, my numerator is always going to be positive, so I'm going to have 2 times 1, 1 squared minus 3, a positive times a negative. This interval here is going to be negative. And finally, let's test something in the last interval. Let's test +3. So y double prime of +3. Well, it's going to be 2 times 3 times 3 squared minus 3. This is going to be a positive. We know my denominator is going to be a positive. So this last interval here is going to be positive. So I can see now, since my second derivative is always changing in each of these intervals, from negative to positive, positive to negative, negative to positive, I am going to have inflection points at negative radical 3 something, 0 something, and positive radical 3 something. And in order to find that something, I need to go all the way back to my original function and plug in my x values. So here's my original function, and well, I can certainly see right off the top here that if I make y of 0, this is going to be 0, my numerator is going to be 0, so I'm going to have the point 0, 0. Now, what about y of negative radical 3? Well, that's going to give me negative radical 3 on the top, and negative radical 3 squared plus 1 on the bottom. Well, that should be negative radical 3 over 4. So at negative radical 3, it's going to be negative radical 3 over 4. And it doesn't take too much to figure out that at positive radical 3, it's going to be positive radical 3 over 4. So these are my inflection points.